Hello everyone, thank you for coming and listening to me. Today I will talk about research paper. This is the design and construction of a cost-oriented mobile robot for domestic assistance. My full name is Tiến Đạt. I am student at Hồ Chí Minh City University of Technology and Education from Faculty of Mechanical Engineering. Um, now, to begin, let's go to the content of my presentation. The recent had four content. Uh, the first is introduction. The second is method or design. The third is experiments and results. And finally is conclusions. And to give you an overview, let's go to introduction. As you know, the number of elderly people in the world are improved, and you can see in the graph. And the highly proportion of dependent elderly people is a great concern because it brings with it economic and health problems. In near future, robot use will be necessary because there will be not enough people to meet the elderly needs. Recently, robots are applicable to even more fields, such as new technology fulfill the function of the assisting people. However, they are expensive robots with highly and complex software. And to solve on problem above, uh, our robot contribute a cost-oriented robot. It can accessible to general population, easy to build, programming, and implement. Next, the design. Uh, this part uh, have three main requirements were considered. First, easily accessible materials. Second, dimensions allow moving domestic space. Finally, easy integration with actuators and social robots. The design is divided three parts. The first is mechanics. Uh, material. We material. The robot structure is designed using aluminum because it is very versatile and that provide the high strength with low weight. Wheels, the mechanism wheels allow the robot to move omnidirectionally and uh, and the robot distribution is divided two sessions. The first session where the wheels, motors, electronics, and batteries are located. The mm, the second session it can contain the robot's main computer, uh, tracking camera, deep camera, and other accessories. The kinematic. Uh, we have this elevation and this elevation. So the calculation of inverse and direct kinematics and dynamics. We have transfer function there and AB control schema will select it have a quick report and it have quick report and statement of range. Um, the second is electronic, the interconnection between their elements. So the figure 4, uh, this is actuator include battery, regulator, motor, and driver motor. This is processing include up square and recovery ATM 32 F4, and this is a tracking camera, and this is a deep camera. Let's go to the software. It divides two sections. The local software inside the robot, the remote software for control and monitoring. The is so in the feature file schematic diagram of hardware software operation. Now we go to the experiment and results. Uh, the robot is built according to the robot design. The structure of the robot allows easy addition of actuator, sensor, and other necessary elements. The figure 6 show on the left design, the left final design, and the right is the build robot. Different experiments are performed to test operation of the robot component. To test the BI control, a variable target function is used and the motor's response is observed. The figure 7 depicts the target speed of the motors in red and uh, the measure speed of the X motor in cyan, blue, green, and black. The robot kinematics are stated using different linear X and Y and rotational force velocity as targets. Figures 8 and 9 so the behavior of the robot at different targets. Um, There's figures show how to target velocity and reached by the measure robot velocity. The green line represents the measure velocity of the robot, and the red line represents the target velocity. The odometry is testing the performance different parts and comparing the target part, the measuring part, and the target and the real robot part. The real robot part of the obtained through the tracking camera with include an IMU. The figure 10 and the figure 11 show the position of the robot performing two parts. The figure 1 a circular part, and the figure 2 a square part. Now we go to the conclusion. The design robot is easy to build, easy to program. Their features make the robot usable by a large population, thus solve the problem of assisting dependent people in domestic environments. All elements work within normal parameters. The table 4 so that the robot is able to execute tasks with low error, and measure its real position, allows the easy interaction of the element, allowing it to be useful in a wide variety of fields. That's all I want to talk about my presentation. Thank you for your attention.